University of Notre Dame is a private university. It was founded in the 1860s, 1840s period of time. It is a moderately large university. Undergraduate enrollment is about 10,000. Graduate enrollment is about 3,000. Some people might know it also has a football team. So our institute, which is called the Institute for Flow Physics and Control, was developed and designed to, from the beginning, to work with industry partners. We're also traditional in that we also get direct funding from government agencies. So presently, our institute gets funding from 11 government agencies, and we work with 24 companies. The government agencies where we get funding are all branches of the Department of Defense, so Air Force, Army, Navy, DARPA, also ARPA. In addition to that, the companies we work with Boeing, we work with General Electric, we work with Bell Helicopter, we work with Honeywell. We write our own codes, we write our own Navier-Stokes codes, but we work with students. And my experience was that the students were most productive and could learn and be productive much quicker when they were using ANSYS Fluent. We also have incorporated Fluent in our teaching of computational fluids to undergraduates as well as graduate students. And so when they get that training both in the classroom as well as on the side in their research, they can become quite productive. In flow control research, our objective is to try to improve the performance of some fluid-based system. So maybe a simple system, one we're working with right now are wind turbines. And so we're looking to improve the performance of a wind turbine by doing, we call virtual shaping of the wind turbine rotor blades. And so the virtual shaping is being done with flow control devices. And so in trying to perfect that, we take section shapes of wind turbine rotors, and then we simulate them in Fluent. We add our flow control devices, and then we determine the impact of those primarily on lift and drag. There are many companies that use Fluent software, and so they're actually happy for us to be working with commercial software that they're working with. First of all, it gives them, they learn something when they see us use it. Second of all, they can transition this to their own work. So in terms of user-defined inputs that we might write for Fluent, then they're able to incorporate them into their versions of Fluent. And so it's an efficient way to transition what we're doing in terms of software flow simulations, to our industry partners. It's difficult to design something in hardware. It's expensive. So we use software to do the initial design to try to reach the optimum in the experiment. So for us, the return on investment is efficiency and the best product at the end. The Fluent software helps us, as I mentioned before, because it's something the students can learn quickly. They can be proficient with it. They can do difficult problems with it. We have written our own codes for flow solving, and they're good. It used to be that you write a code for a flow solver, and that was your PhD. Okay, in the early days that was reasonable, but it's not reasonable now. Now we have these tools and so we learn to use the tools and make the best of the tools. We're not trying to develop our own flow solvers. Our intent is to use flow solvers to do what our mission is, which is flow control.